First up, we've got Phil. Phil's a very experienced principal solutions architect, lead developer, and a head of practice at Inner Wisdom. He's got over 4 years of AWS experience and over 15 years of experience in gaming and social media startups. He's been responsible for running production workloads of over 200 containers in a performance system, and is now a specialist productizing machine learning. So Phil, if you'd like to share your screen and take the stage.
Okay, evening everybody. Can you hear me? Just make sure everything's working okay.
I can hear you. I can see your screen.
Excellent.
Let's make sure we see the right part of your screen when you hit the play button.
Here we go.
Yep, that looks good to me.
Good.
Off you go.
Excellent. Good evening everybody. Yeah, as John just said, I'm Phil Basford. I'm Head of Solution Engineering at Inner Wisdom, and I'm going to talk to you tonight about how to productionize ML, and specifically a focus around one of our customers that we do a series of projects with called Aramex. So Aramex is basically a logistics company, a bit like FedEx or UBS or one of those. That is specific to the kind of the Middle East region. They have a head office located in Dubai, and they're shipping parcels internationally as well within region. And as mentioned, I work for Inner Wisdom. Inner Wisdom is a premier partner, and we specialize in AI and ML for our customers. So with Aramex, we're helping them perform and go on a digital transformation. At the heart of that experience is using AI and ML. Two kind of standout use cases is address prediction and time slots. Address prediction is quite a unique one for their business. They have an issue where basically when they capture addresses, etc., they're very unstructured as opposed to kind of the Europe or North America, so they have to process those addresses and work out kind of where they are. So we're using a mixture of NLP and geospatial custom models to predict basically where in the world, given a descriptive address based around landmarks, that a consignment will need to be delivered to. And then transit time is about predicting how long it will take to get there, so the time it takes to predict from being picked up to delivered. And then other aspects of their journey around understanding the profile of their consignee. Before Inner Wisdom got involved and we did the projects with the Aramex, they were facing some hurdles and some barriers to innovation. They didn't have a specific machine learning environment that was enriched for them. They had issues around data access and basically had legacy on-prem systems. And then they didn't have kind of the modern ML kits that you need a grunt underneath it, including GPUs, instances, and that kind of thing. So together with us, our specialties and AWS's cloud and their rich ecosystem, we were able to help Aramex. So some general background is AWS have been investing quite heavily over the last 2 or 3 years in ML. To be honest, Amazon as a company has been using ML since they were more or less founded to provide you those recommendations on the bookshop, as they like to call it. In recent times, they've invested a lot in building out a comprehensive stack around machine learning. So at the bottom, you have those machine learning frameworks. I'm not a data scientist, but I'm familiar with lots of them. But so in addition to that, there's lots of hardware around GPUs and instances that you can use to power your workloads, which we become all familiar with. The middle layer is kind of the layer for the data scientists, but it's also where you start to productionize and the life cycle. AWS started out with a small kind of service, SageMaker. It was kind of an instance notebook and INFERENCE, and it's grown and grown and grown. And SageMaker now is more of an entire platform around machine learning. And we'll focus a lot in this talk about how to use bits of it, particularly the inference bits, but we also now have the IDE. And then for the people like me that are not fully fledged data scientists, that have to grip on models, you can also use things like the high level ML and AI services to give you kind of a very good ML experience and embed it very well within your company or your product or whatever you would like to do with it without having to know all those levels. So we'll focus particularly around SageMaker. So SageMaker has grown. We're particularly focused on the inference side of productionization, but it's a whole suite that incorporates all of the life cycle, from discovering data, manipulating it in a notebook, running Jupyter, to refining that model using hypertuning and getting it ready to be put live. And then there's a process of putting it live and doing inference. And then in that process, there's the routineness of doing ML ops, which is the process of retraining models as you need them on new and changing data. For example, in the Aramex case, where they are working out where addresses are, we are retraining those models constantly to keep them up to date so they make the best predictions possible. Behind all this, we like to well architect our stuff. So those, hopefully lots of people do know it, but in order to get the kind of the best non-functional characteristics out of your architecture on AWS, and AWS all base it around the well-architected framework. That has 5 principles to it. Operational excellence is about running and operating your workload. Security obviously is about how it's encrypted, how it's secure, and then you have the kind of triangular relationship of cost optimization, performance, and resilience. And a lot of what I'm going to talk about in a minute will be focused on those areas. For those who don't know, about 2 months ago, Amazon launched the machine learning lens with the architect framework. If you're more interested in this subject after I finished, I encourage you to go and read that. And also they do a data analytics one, which is also really useful. So the best way we kind of achieve something that's well architected on AWS is kind of going fully cloud native and going down the serverless route. So we're using lots of that in the solutions we build for Aramex and generally, and that involves using things like API Gateway, Lambda, and S3. So API Gateway and Lambda and S3 are really good for embedding, and then we're using DynamoDB to store hot data, reference data. And lastly, actually, SageMaker itself is a fully managed service. And kind of the main advantages that you should glean from this talk is that it will help you do lots of that. This is kind of the overall solution that at a very high level that we developed, and it's very it's actually quite simple, but it actually accomplishes quite a lot and scales quite well, and we'll come on to that certainly in a minute. So to embed this ML model within the wider kind of Aramex or any enterprise, we typically integrate it using an API. That API is built using API Gateway, and that then calls a Lambda, and that Lambda process will pull out any reference data you need to do any feature engineering, and then we'll call the SageMaker model deployed in as an endpoint to make a prediction. Behind that, we obviously with the good data and being able to get access data there, and that we've covered probably a lot in the next talk, is about how you capture that data. We use a tool called Matillion to pull it into Redshift, and we use lots of ETL processes and pipelines to clean data and manipulate it into the right format, and ultimately that's stored back into S3 as training data sets that we use for retraining models. So we're going to focus a lot now on how SageMaker, and particularly the inference side of SageMaker works, and some of the kind of characteristics it has and some of the insight that we've got over time into it. So SageMaker itself, endpoints are broken down into kind of a few conceptual elements. You have the endpoint itself, which sits behind the AWS APIs. So that includes everything like authentication, encryption, IAM roles, everything for any services that call it. And then behind that you have your configuration, and the configuration will have multiple variants. A variant we'll come into more detail later regarding some of how to deploy, but it's a very good way of doing A/B testing. So if you've got one model that you've been using for a while, and then you've worked on a new theory and a new set of parameters and changed the feature data, you can then change and deploy a second model and sample X amount of the traffic going to it, so you can evaluate its performance against the original model. And then behind that configuration, basically AWS has, and there's a big clue to kind of how SageMaker works, it deploys a number of containers. So each inference engine and each training kind of each training image has a Docker, and that's running behind the scenes, and that does things, and that can connect things like VPC, so you can connect out into your VPC, and it also will do help with your security. And there's other security layers that I'll come into a bit later regarding how you can use encryption around S3 and KMS, and further details around IAM. The key thing to note is most of this framework's immutable, so when you change it, you have to deploy changes in chunks. So how does that work? So it uses a container. So when you're running lots of when you're launching Inference and SageMaker, what you'll do is give it a Docker image, and it will go and fire up the container behind it. How SageMaker communicates with that is that it passes on your requests, basically. So it will in the plane, but inside the actual kind of SageMaker, and it will take your prediction and it will perform that request against the locally running container on an instance within SageMaker. That instance will process the request and it will give you the prediction back. That's kind of a major advantage for this is that then SageMaker doesn't need to worry about what you built your container in and how it runs. It just needs to run a Docker image for you and perform a basic HTTP REST request. And most of the models, you would then load the actual trained model from S3 for it to run at runtime. AWS give you a full suite these days of things you can run about. So there is TensorFlow, there's XGBoost, there's PyTorch images. So whatever algorithm framework you want to use, they normally have a quite comprehensive set. However, if you really want to, and I have done, you can actually build your own custom one for a specific need. And one of the couple of Aramex situations, we did that. And that's just a question of building a Docker image. So using Docker kind of poses a lot of questions. Basically, how ephemeral it is, how long it lasts, how many network it uses if you enable VPC, does it use EKS, does it use ECS, is it Kubernetes? It kind of opens a whole door to those kind of deployment questions. It also opens a kind of some ML kind of questions around, well, you're normally using a CPU because you want to use a CPU fully, or you're using a GPU because you want to use a GPU as a dedicated resource. So if we're using Docker images, you kind of got to think about resource contention. How does that play out? So a lot of that's involved. So we wanted to kind of look a bit deeper. So how do we do that? So we run a couple of experiments. So we deployed, first of all, a notebook instance and looked at the VPC. So we deployed inside of VPC to see how the networking worked. That decreased the network range. So we could see, okay, the instance got allocated to a single address. And then we trained a model, and we used a standard XGBoost model for that and a standard open data set. And then I trained that model, and then we deployed it into 2 subnets. And as we deployed it into the 2 subnets, we could actually see the 2 subnets decrease in terms of network address availability. So that kind of gave us a clue that a instance used a network address, and it used an ANI behind it. So that gives a big clue how the networking kind of side works. And then we performed a series of experiments to understand the nature of it. So to do that, we used the open source serverless artillery to batter and fire about 200,000 requests at it over a 2-hour period to give us a kind of a load of what it would expect. The most interesting part of this graph, there was 2 main interesting parts. One is it hits 200%. So that basically indicates that it's using 2 instances, which is what I told it to use. So that's good. So it used all of those 2 instances fully during that time period. And then halfway through, it kind of drops down. And well, I investigated that, and it kind of didn't make a lot of sense. There wasn't any evidence in the logs, etc., etc. And I investigated further and further and found out actually it's because it's the instance type I used. So when I ran this experiment, I used a T instance type, a T2 medium, and basically at that halfway point, the T, for those who know T instances, they have a burstable CPU, and once you exceed your balance, then the performance drops, and that's basically what happened at that point. So it kind of crashed, and then the good news is it picked up that it crashed, and it also healed it, and then so it brought it back up with another instance after about 10 minutes, which is roughly the kind of cool down and the the warm up time. when you're scaling in and out of groups. So that's kind of cool. So it also means that we're only ever using 2 instances for the whole process. So we know that at that point, thousands of requests can be kind of utilized on these boxes at one time. And we've kind of proven some of the reliability underneath SageMaker. So if you lose one of your instances, as long as you've got more than one, it will recover basically. And you should try and plan for that when you start to productionize your workloads. I got this, which is one of the best emails I got. I got a nice email from the SageMaker team actually telling me I'd been, well, silly because I'd been using a T instance and it was not the thing to use, and that I had crashed the endpoint. So they gave me a nice email telling me how naughty I'd been. So, and that's fair enough. It just kind of proved what was going on, and the reason why was because it was a T, and they recommended using a bigger instance basically. So I did. So ran the experiment again. This time I used M5 instances, a proper big boy instance to run it on. As you can see, that tracked at 200 CPUs. That used all of the instance throughout the entire load. It used 2 instances all the time, and we didn't suffer the same issue when it came to crashing. So it stood and was resilient for us. However, we might not want to run so many instances at a time. There may be instances when we want to scale beyond this. So upon looking through the deep depths of the SageMaker documentation, and for those who've been there, there is deep depths to it. There is the ability to actually set auto-scaling onto SageMaker as an application auto-scaling group. So that allowed me to set a minimum and maximum. So I ran another experiment where I set the minimum to 2 and the maximum to 4, and I set the desired at that point to 2 to start off with. So we started at 2, which really was the instance count, so that became the desired count at that point. And you can scale on CPU, you can scale on memory, but also SageMaker exposes you a raft of cloud matrices through CloudWatch. So I use the invocations per instance in SageMaker, and that gives you a more natural kind of graph to it. So we run the experiment with auto-scaling. And this is kind of what happened. So kind of the same kind of improvement happened in terms of number of requests. The most interesting bit though is that it never exceeded the maximum CPU across anything, and it started scaling up about halfway through to more instances, and looking at it, it went up to 4 instances by the end of the process. So it scaled rather nicely and worked well. Why is this important? It's actually all about latency. So given the first experiment, we saw it went to 200, but the problem was that latency went up, and latency is basically the time it's taken to serve your requests back to your business or your app or whatever you're using SageMaker for. So at this point, it's encouraged to keep that low as possible, and particularly in the Aramex case, we're going for 100 milliseconds or less kind of territory. So anything that kind of went above that would be a problem. So kind of that's very important to see that when the CPU started to be hit on the first one without auto-scaling, and it couldn't scale out, that latency happened because it was processing these requests and had to wait on the back end to actually process them for you. But when we did the auto-scaling and we were able to scale up the instances, because it never hit 200 or above 100% CPU, basically the latency was never a problem, and it kept within the normal kind of range. I did this overnight, you can see, to have two clear operations. The good news, it cost only about $42 to this entire to those 2 experiments. So that was, it's kind of overall, it's quite cost effective to run SageMaker. However, as well as this is kind of the trade on that triangle of well-architectured things, be very careful. You need to be, don't go too much, don't give it too much juice, and don't give it too many instances. You have to know your instance, and it comes back to that scaling and run that matrix, and knowing the number of requests and invocations that a model can take on the instance types that you are running it on, and the minimum you need and the maximum you need, and when your peaks are, because not doing so can cost you some considerable money, especially when if you're running a GPU workload. GPU work but services and instances are really expensive generally, and they are, and they'd be even more expensive if you have to go and buy the kit yourself. So it's nice to have that on tap on AWS, but at the same time they can be quite pricey. So you want to be very aware of your cost and also optimize. So we did a couple of things during the life cycle of the project over quite a long period of time, actually, to kind of work out the workload. So first of all, we started off with a 2x large. We changed that instance size down, so we went to a large, an M5 large. That was a bit better. And then we thought, okay, it's very CPU intensive, so we changed to a C type, and that was a bit more, that was cheaper, but it had more CPU. So again, we could kept running less instances, but each one could take more invocations, so we could kind of keep cost optimizing it down. The one thing to say, and this is something generally fed back, is there's no reserve instance or saving plan currently for any of the ML workloads on AWS. So ideally, once you get in a stable state and you know you optimize all this as much as you can, you would ideally go for a reserve instance, and that could give you up to 60% saving if it was a regular like EC2 instance. So something like that is worth knowing. But at the end of the day, kind of SageMaker's done a lot of the undifferentiated heavy lifting here for you. So you're kind of paying a little bit for the fact that they've done all of this magic for you in the background. Kind of in addition to kind of running it, there's the ML ops bit regarding SageMaker. So once you've got it live, got it in steady state, you want to refresh those models and update them so that the accuracy doesn't drop, and it kind of keeps giving you good value to your business. So there's a really good open source project from AWS called Step Functions Data Science Software Development Kit. If you're in this area, I encourage you to go and look. It has the kind of some good capabilities. So it allows you to run GUI jobs, and it allows you to run Fargate and ECS jobs, and that's quite important because sometimes even GUI's not kind of doesn't give you exactly what you need. You need to be even more programmatic. So you might want to send run a Docker image of your own that does some stuff to clean or manipulate that data in an even more detailed way. And then it can call into SageMaker and run training jobs for you, and ultimately deploy your endpoints. And I'll come on a bit more about the process. But what it's doing behind here is kind of creating you a step function that glues all those elements together in a nice way. So then behind that step function, you can trigger it when you need to. So if you detect a drop in accuracy, or if you need to train it periodically, you can check a CloudWatch event to trigger this, and this will go and pull the data down, training data down, it will train it for you, get it ready, verify it, and then deploy it. So if you're going into the kind of the ML ops space, this is where you should look. In terms of deployment, so using what I said earlier, regarding variants of the endpoint, etc., and things being immutable in terms of configuration, this kind of, it seems a bit weird at first when I first grappled with it, but actually it offers you up some nice DevOps style stuff that you can do with SageMaker. So as I said earlier, you can run a kind of canary. You can use an A/B style deployment to take a small sample set of your traffic on a new model and evaluate its actual performance in production against an old model and see if it's actually improved, and how, if you're retraining, for example, periodically, you could take the same data and compare so that you know that the retrain models are maintaining the accuracy. So using the kind of canary variant is a good way of doing that, as opposed to the rolling variant, which is kind of the default, where AWS will deploy your new model completely and then kill your old model once it's fully ready. And then you can also do blue-green. So if you want a rapid switch, you can actually do a blue-green style deployment. So you can switch all the traffic between them very, very quickly. And then lastly, on the configuration, you could adapt the canary model to be a linear, because you can perform, whilst everything else is immutable, so you can't change it. There was actually a specific API in SageMaker that allows you to update the weights and the amount of traffic going between your variants. So that would allow you to move traffic across, starting at 10% and then all the way up to 100% as you want a gradual deployment. So as you're building out your kind of your pipeline, you can do this kind of thing. As I mentioned, there's extensive monitoring around SageMaker. It is fully managed for you. Make sure you deploy more than 2 of them, so you do have fault tolerance, and it is achieves that reliability kind of and resilience pillar of the well-architected framework. But there's also ways you can supplement that, so you can look at all the metrics, and common ones are around CPU, etc., and number of errors. So make sure you kind of monitor them as well as you would monitor any other part of your workload. And the good news is that AWS exposes you the same kind of level as you would if you were just running EC2, for example. So that's really good. General tip, even in not in machine learning, but if you're doing anything or any alerts, is make sure that they don't conflict too much, and that there's also grouping now that's just come out, which is quite useful. You don't, if your endpoint dies because of one thing, you don't want 6 or 7 alerts all firing off telling you that it's broken. One's already told you that it's pretty broken, so don't send in recovery, and the on-call pager going balmy is kind of the takeaway from that. So make sure they complement to each other, and again, you can also configure alerts to be tiered, so make sure you know beforehand rather than something comes completely critical. Next thing is, is that SageMaker is actually completely integrated into X-Ray. So with Aramex, we had to achieve kind of below, in the end, we achieved below 135 milliseconds at the 95th percentile. So it's quite a very performance solution. To do that, what we use is we used X-Ray very extensively to tune and make sure that how long each call was taking to each bit of the solution, make sure DynamoDB is retrieving fast enough, have you got the partition right, is SageMaker responding quick enough, etc., etc. So you can, if you just embed X-Ray in the Lambda, you kind of get exposed to all that. So as you would do in any other service kind of application that you're running on AWS. However, you can also pass it all the way down to the model. So some of those, I mentioned earlier, you can build some of those really custom models of your own. And because you're behind an endpoint, you can actually pass all the X-ray information all the way down into your own model. And then behind your own model and inference engine, you can actually then start to expose X-ray, so you can actually see how some of your model is performing even in the depths of SageMaker running on those instances you can't really get to. You can still see the kind of the performance of each part of your model if you illustrate it with, instrument it with X-Ray. Just want to talk about security a little bit more. I kind of skated over it. It is the base rock, so just some general things. The SageMaker is built based on all the AWS best practices, so you can lock down your access to it and where it's got access to using IAM roles. So make sure you use these privilege in your IAM roles to make sure that you lock that down. S3, everybody, it's like the most used data store in machine learning. Everybody uses it in machine learning. To do that, just make sure that you do all the good stuff. No one wants to be one of those public call outs about somebody hasn't got their bucket quite right and they've exposed their data. So make sure you do have encrypted, make sure you have resource policies around it, make sure you have logging on so you know that if someone's tampered with it or done something with it, you know what's happened, and have versioning on it. So if that data gets corrupted or changed or whatever, unintentionally probably, you can still go back to an earlier data set and take it from there. And then around those public securities, I'd always encourage you to also use KMS, and particularly if you're using PPI or PCI DSS data, make sure you're using your own encryption keys, which basically means that it's encrypted your own way and you have to grant individual access to that key. So that means basically if somebody came along and accidentally opened up your S3 bucket, people can't actually get your data because it's still encrypted with your own key, so they have to have the key access as well as the S3 access. So it's kind of a double layer protection, which you should ensure. I focus a lot on the networking stuff in this talk, because lots of corporate people have information security policies that require stuff to run inside a VPC, run inside their existing network. They can't go to the public internet. So you have to use it within the VPC with private links. So I encourage you, if those are your security policies, to make sure you run SageMaker inside a VPC. The good news is, kind of with the load testing and everything I did, we could see that it needs 1 or 2 addresses basically for lots and lots and lots of inference. So, and there's no kind of worry like you'd have with Lambda of exhausting the kind of network range if you give it a decent CIDR. And lastly, it's kind of common sense on the security side is don't have more access to more data than you need. If you don't need the PPI information to do your machine learning, make sure like your data engineers or somebody's removed that from the data set before you use it. The best way is just not to have it there. If it's not there, it can't get exposed. So kind of only use your kind of the personal information when you absolutely need to for a use case that must have it. In most of the ways you can tokenize it, anonymize it, normalize it, or standardize it in such a way that you don't actually need a person's email address, a person's actual kind of payment details. You can pretty much get there without that most of the time. And so lastly, where does this all lead to? So we successfully delivered this project, and now we're delivering multiple projects with Aramex. They saw a 74% increase in the time it took them to predict how long it took a transit time consignment to go from one place to the other. That was also improved their call center volumes. It kind of lowered them by 40% because people could go and get an accurate prediction of where they were. And we managed to achieve all of this in kind of initial 8 weeks project with them when they were struggling through their data center and everything for 5 years to start there to get that digital transformation going. We allowed them to achieve that first step in 8 weeks, and now we've built out lots more projects around for them. And that's kind of a testament to kind of our capability, but also kind of the serverless style of AWS and the way you can rapidly deploy that stuff at a really good, competent level, really secure and optimized level. And that's kind of what this process done. Behind that, there's some pretty cool facts. So it handled 1.2 million updates a day. Every 15 minutes. That's quite a cool volume. So pulling all that data in from the data center is quite intensive, but we managed to achieve that, and that's something they just were always struggling with before. So using Matillion and our data engineering skills, we're able to pull that data into and make them a data lake, and then they have a data lake that's 7.2 terabytes. It has got, we keep 3 months of data in it. Overall, it's got 77.5 years worth of data they can go back through for all their machine learning and all other tools and BI they want to do over it. And now we make over 20 predictions a day on that one use case, and we're achieving that 135 millisecond response time. So it's a very performant system. It's a very big system, and it's highly tuned. Some reference stuff, you can grab this later, but a couple of my blogs got some stuff that we invent, useful sessions around this. One of them was actually this presentation, or a variant of it was a reinvent session that Alex spoke at, and there's some more detailed thing about how to build your own algorithms, and go and check out that step functions SDK that allows you to do that ML ops. That's very useful. And that's it. Ready for those questions, John, if there are any.
Yes, thanks, Phil. I'm always inclined to trust presentations that have graphs and site references at the end. So you could have been talking absolute nonsense, and I would definitely have been like all in for the ride with those graphs. Yeah, we have one question so far from Shaswar, who asks, "What if we have sensitive data in a private subnet which has no internet connectivity and want to use SageMaker?" You might have covered this in your security section, but maybe let's address that.
Yeah, so generally there's two things. So obviously, you can run both a netbook instance and also the endpoints all inside of VPC. So that's the first thing. So you can just keep it all local. In terms of how other components talk to that, I would recommend at that point using something like private link. So, you know, architecture, there's a Lambda. Make sure that that Lambda uses private link to communicate with the SageMaker instances and endpoints inside that VPC. So that's kind of the two bits to how to accomplish that.
Gotcha. I know people inside AWS will be really pleased to hear you talk about Private Link, because I happen to know that they're on a bit of a sales push with that at the moment. So if you don't know what Private Link is, then do go and look it up. It's got very specific use cases, but is quite a useful thing for SaaS vendors to expose services without also exposing all of the rest of their VPC. A question from Jamie French, who asks, "What do you believe Matillion offered in this solution?" Great talk, Phil, was the other, not part of the question.
Thank you. So we particularly used it, two parts really. One is Aramex had previously kind of experimented with change data capture as a kind of an ETL extraction from, a data ingression point from their on-prem system. They found that had performance impact on the underlying on-prem SQL Server instances. So what Matillion kind of offered, as opposed to something like DMS or something like that, was that it allowed us to do change tracking, so that we could then just pull in the changes that way incrementally. In addition, it also offered us a comprehensive kind of ETL suite that is very good and very developer centric. So it's very good at building out those complex ML transformations that we have to do.
Cool, great stuff. Thanks, Phil. If you have further questions for Phil, you can type them into the Q&A box, and I think Phil's going to stick around for a bit and maybe answer some of those with his keyboard rather than with his mouth. And we'll move on to the next speaker. So thanks there, Phil.